first understand what the goal is. This is a linked list without a cycle. You can start from the head and move on through the whole linked list, and we would not encounter a cycle. Let's look at a linked list with a cycle. Notice how the node with value 4 loops back to the previous node. This is what we call a cycle. The problem asks us to identify an algorithm that can distinguish between these two linked lists. So there's a few ways to do this. One, we remember the values that we've seen as we traverse through the linked list. In this case, we would remember the values 1, 2, 3, 4 and 5. And if we can start from the head and move all the way to the last node, which has no next pointer, then we could say that we've not encountered a cycle. Of course, we would be using order of n memory for the dictionary. Here's how it works for a linked list with a cycle. As we move through the linked list, storing these node values, at this point we realize we've already seen the node value 3, so we can conclude that there is a cycle. Again, remember, this only works if your linked list has no duplicate node values. For example, this would not work for a linked list with duplicate node values, such as in this case, even though this linked list has no cycle, we would falsely conclude that there is a cycle because of these duplicate node values. Alright, clearly this is not the best way to do this. This two-pointer approach is pretty useful for linked lists. You're going to encounter this in a lot of problems. Alright, here's how the two-pointer solution works. The goal is to start at the head, but now we have a fast and a slow pointer. And the goal here is to move the fast pointer twice as fast as a slow pointer. So the way the solution progresses, or so the way the iterations progress, notice how the fast pointer traverses the whole cycle and then comes back around, while the slow pointer has just started making its route. And the goal here is to, in some way, for these two pointers to collide at a particular node. Where doesn't matter. If is the point. If they collide, then you can conclude that there is a cycle. Because remember that this wouldn't happen if there was no cycle. So the fast pointer would have gone all the way to the end, and the slow pointer would follow, and we would never see a collision. The only situation in which the fast and the slow pointer would collide or be on the same node after starting at the head is if there was a cycle. Let's think about this. Why does this work? This is the most important part. We can prove this by contradiction. This is really the cool part about this algorithm, because I could just end it here and say that, hey, this works, but what's the fun in that? Let's figure out why this works. This is an interesting idea to think about. Proof by contradiction. Proof by contradiction. Let's say I make a claim that the two pointers would not collide, even if there was a cycle. I'm stripping the numbers and just thinking about a cycle. Let's say my fast and slow pointer are one node apart. This means in the very next iteration they would collide, because the fast pointer would go 2 nodes ahead and the slow pointer would go 1 node ahead, and they would collide. So this is a situation where if they were one node apart, they would definitely collide. And if they're two nodes apart, then in the very next iteration, they're going to be one node apart. Why? Because the fast pointer would catch up to where the slow pointer already was, and the slow pointer would have gone one up to the previous case we just proved. If they're one node apart, then they will collide in the next iteration. Alright, so you see where I'm going with this. Let's say they were three nodes apart. This means in the very next iteration, they're going to be two nodes apart. And we just proved that if they're two nodes apart, they're going to collide in two more iterations. So really, if you think about it, you can do a sort of proof by induction where for any k, for any value k, which separates the number of hops between the fast and slow pointer, you can imagine in the very next iteration, they are gonna have a distance of k minus 1, because the fast is going to reduce the distance by 2 and the slow is going to increase the distance by 1. So overall, the reduction is k minus 1. And of course, proof by induction k minus 1, that means the next iteration is going to be k minus 2. And at some point, this is going to become 0 for any value k, any positive value k. So proof by contradiction, we just see that no matter what k you start with, the fast and the slow pointer will collide. And that's pretty cool. And that's a pretty interesting algorithm that works. And if you think about it, you can do this. And something that I've been thinking about, and I don't know the answer to this, is will this still work if we start? Something that I've been thinking about, and I don't know the answer to this, is will this still work if the fast pointer moves by 3 times as fast as the slow? Or is there something special about the value 2x for the fast pointer? Let me know in the comments.